is the first video for the year and your first assignment. So this is a review chapter, and section 1. So we're going to talk about sets. So selects, as you can see, is a collection of objects, and then each uh, thing in that collection is called an element. So an element is just an object within that set. And this is set notation. These brackets, you can just do an S and then do a 2, and that kind of creates it. So it could be 1, 2, 3, 4. So that'd be 4 elements in this set. And so that's a set. It's just a collection of things, and then element is just what's in the set. So if I have this set here, 1, 2, 3, 4, an element, say 1 is an element of, so that's meaning a member of. That's little like E with a line through it. Means a member of. So 1 is a member of this set 1, 2, 3, and 4. So that notation is just member of. Member. So then say 5 is, this means member of, so a slash through it means not. So 5 is not a member of this set. So this is member, this is with a line through it, not member. So finite versus infinite. Finite just means that it ends. So finite set is just a set just like we described before. 1, 2, 3. So that's a finite set. An infinite set means it goes on and on and on. So it could be something like 1, 2, 3, dot, dot, dot. And that dot, dot, dot just means it continues the pattern. So this would be 1, 2, 3, 4, 5, 6, 7, and just keeps counting by ones. Or a good finite set could be, or infinite set could be 2, 4, 6, dot, dot, dot. And so that would mean it's counting by 2. So that's infinite. Finite just means it ends eventually. And so the numbers or the elements in that set would all be listed. So when we talk about subsets are sets within sets. So here's an example. So we have this set 3, 6, 9, dot, 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 27. So that's a finite set. The pattern is just going by threes, but it does end. So notice that it does end there. So it is a finite set. And so a subset is this symbol, little c with a line underneath. And it kind of looks like less than or equal to, because basically that's what kind of a set is. It's sets within there. So 3 and 6, that can be a set. 3 and 6 is a set, and that set is contained within this bigger set. So it's a subset of this set. 3, 6, 9, dot, 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 27. So it's a subset of that set. Also, the whole thing, even the whole thing, this is a subset of that set. So that's why you kind of have this little line under or equal to. So this whole thing is a subset on itself. And then you have the null set, and the null set is, you can say null set or empty set. And so that means that nothing, that's the empty set. Just this 0 with a line through it means empty. It means nothing is in that set. And then the universal set is the set of all things. So if we're talking about say just whole numbers, so 0, 1, 2, 3, 4, and it goes on forever, that would be, it could be the universal set. So, or the real number system could be the universal set, or the complex number system could be the universal set. So it's everything in the set is the universal set. So it's the set of all things, and you'll see in the books when it kind of compares your set to the universal set. So usually when it's talking about universal set, it's comparing to like all whole numbers or all real numbers or all complex numbers. So when we talk about subsets, we can do this by Venn diagrams, right? So here we might have a set is 2, 4, and 6, and then we have another set, say is 3, commas maybe, 3, 6, 9, right? So this set is counting by threes, and this set is counting by twos, 2, 4, 6, and 3, 6, 9, and they share this one 6, right? So you can represent by sets and subsets. So 6 is a subset of actually both counting by twos and counting by threes. So Venn diagram is a way to kind of do sets, show the different sets or what's contained in these, right? And these are elements. 3, 6, 9 is an element of that set, and 2, 4, and 6 is an element of twos. Okay, and so finding the, so we talked about subsets. Here's finding the complement of a set. Now, complement of a set basically kind of means what's not in the set. So here, this is our universal. Universals use capital letter U. This represents everything that we're kind of talking about, 1 through 7, and a complement, that, so this little dash here, that little dash means complement. So a complement means everything not in A. So everything not in the set, but in the universal. So 1, 3, 5, and 7. So you just kind of mark those out. 1, 3, 5, and 7. So everything that's left in the universal is your complement. So 2, 4, and 6. 2, 4, and 6. So everything not in your set, but it's in the universal. Okay, so intersection of two sets is by upside down U, or an N, I guess. So intersection means what's in both sets. Okay, what do both sets have in common? So if we look at A here, so looking for what they have in common. So they both have a 15 and they both have a 25. So the intersection between these two sets, or Venn diagram, here's the first set, 9, 15, 25, and 36. Then you have another one, Venn diagram of the second one, 15, 20, and so on, 25. So what the Venn diagram would look like is there would be overlapping. The overlapping would be 15 and 25. And then all the rest would be out here and out here for your Venn diagram. So what this equals is the set, the union of this set is the set 15 and 25. So if they have nothing in common, then it is the empty set. And the empty set is just this. Union with a U. So union with a U is just whatever's in the first set, second set, or both. As long as they have it in one of them, then it's in the union. So all these and all these. So what this equals is just all of them, but you don't write it twice. So like 1 is repeated, so you don't have to list that twice, but you do list it. So 1, 2, 5, probably should put them all in order, but not. 14, 3, 4, and 8, right? So that would be the union, would just be all of them. And you just, if they're repeated, you don't list them twice. So the union is just what's in each set, or both. So as long as it's in one. Okay, so that's it for the first section. Keep it short, you're just taking notes. We'll work on problems in class. So, but let's just go ahead and do this problem. Determine if it's true or false. A is a subset of B. So we look at A. Is everything in A contained in B? So everything in A, for A to be a subset of B, it means everything here has to be inside of this, right? So that is false. But B is B a subset of A? So is B a subset of A? So looking at B, 2, 4, 8, 10. 2, 4, 8, 10. Yes, this one, this is true. but the other way it would be false. Let's look at number 2 here. Determine whether the statement is true or false. What's the intersection between 3, 5, 9, and 10? And that intersects with the empty set is that 3, 5, 9, and 10. Remember, to be an intersection means that you're looking for what do they have in common. So what do this set and this set have in common? Well, the first set has 3, 5, 9, and 10. The second set has nothing in it, so they have nothing in common. So this is false. But if you would switch that to the union, then it would be true. True. If you switch to the union, but since it is an intersection, that is false. All right, so that's it.